this is going to be the part where I'm going to talk about the practice problem that we assigned earlier. Problem number 51. So the question goes as follows. A plate shaped like an isosceles triangle with a height of 1 is placed on a vertical wall 1 meter below the surface of a pool for waters. See figure, which is the one I drew right here. Compute the force on the plate. So, so I redrew the figure, and it's slightly different from the example we gave, but I'm sure you guys will do fine. So as always, we're going to start to look at the function for the width of the object. So looking at the very right side of the object, we're going to see that the function is going to be y equals 2x, since when the x varied by half, the y increased for 1. So y equals 2x. And if we take that in terms of y, it's going to be x equals 1/2 of y. However, looking at this, this is going to be 1/2 of our width of a triangle, uh, since it's only the function going to the y-axis. So in order to have the full width, we're going to times 2. So now we know the width function is going to be 2 times x, which is going to be equal to y, for y between 0 and 1. That's going to be a width function. And now we're going to our depth function, which is going to be 2 minus y. And some people might get stuck on here because the depth that is affecting it is actually higher than the object itself, and that might be a little confusing for you guys. And the depth that we're looking at here is actually, since the pressure varies by the depth of the water, not the object itself, so we want to account for the extra water. So knowing that the, uh, the the object is actually submerged 1 meters below the swimming pool, we know that the highest point is going to be 2 meters instead of 1 meters, uh, which is going to which once you get it, I'm pretty sure it's going to be easy. And now, knowing the width as well as the depth function, we can plug into our master function, which is going to be a definite interval from 0 to 1, and p of pg times depth times width. And people are going to ask, why is it 0 to 1? Shouldn't be 0 to 2, since you just said the depth of the water is 0, is going to be at 2. However, the range that we integrate is actually going to be the height of the object itself, because there's nothing above the object that it's going to have pressure on it, right? So always remember the upper limit is going to be the very upper part, very upper boundary of our object. So knowing that I'm plugging everything in, I'm pretty sure it's going to be a very easy integral for you guys, knowing going through all the semester already. And here are just the steps I did it. And always note that for water problems on Earth, basically, P is always going to be equal to 1,000. 1,000 kilos per meters cubed. And so gravity is always going to be